Hey, this is going to be a video about trying to count in different number systems. So if you've ever seen something in binary like 1 0 0 1 1 0 and you wondered what exactly that was supposed to mean, this video is supposed to help you out. So you're probably familiar with a normal way of counting, the way that you count in your head, probably, where you have a ones place and you have a tens place and a hundreds and a thousands and then a 10,000s, and it carries on, right? Have you ever thought about why we call this the ones place and the tens place, the hundreds place? You might not remember this, but I'm pretty sure you learned it when you learned how to count way back in the day. So we do it like this because we say that we have a base 10 number system. I'll show you why a base 10 number system gives us these particular things in a second. We use base 10 because we have 10 fingers, right? And you count on your fingers at the beginning. So it's pretty much an accident that we use base 10. It's because we happen to be monkeys with 10 fingers. If we were aliens, our numbers would look very different. So this is why we count this way. And you got to know this before you know binary and hexadecimal and things like that. Let's say I want to count apples. I have one apple. So I'm going to say I put a 1 here. Now I have 2. So I'm going to put a 2 here. 2. And it's the same for 3, 4, 5, 6, 7, 8, 9. It's the same up to 9. So everywhere up to 9, I just increment the digit here, make it go up 1. But once I say 10, now I'm not going to count anymore. I don't want to have a number like a signal for 10. Like I don't want that to be 10. Because if I started making a specific picture for every single digit, I would never end, right? I'd have to have a million different digits. So to avoid that problem, I'm going to say this right here, this is a group. So you say, now what I have is I have one group of apples. And you might say, a group of how many? Well, a group of 10, because we're using a base 10 system. So now I can count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what I have now is another group, right? So this 10 adds one more to here. So now I say I have 2 groups of apples. That's why this right here, we say is 2, 0, because I have 2 groups of 10. So you can imagine I make a bunch of groups, right? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 3 groups, on and on and on, until I have 10 groups. Now when I have 10 groups, what happens is I say, okay, I don't want to have an infinite number of digits here. That would be too annoying to have a million different digits for a million different numbers. So I'm going to say what I have is I have 1, and then I have 3 here. Let's just say I have 7 more of these. So I have 10 groups of 10. Well, that number I put here. So I say, okay, I have one group of a group of 10, 0 groups of 10, 0 left over. Maybe you notice that 100, that's 10 times 10, right? 10 groups of 10. So similarly, when I have 10 groups of 10, that's when I put a 1 here. This turns into 0, and what I have is 10 groups of 10. And so on and so on and so on. So it's a base 10 system because when we reach 10, that's when we decide to move it up and say, well, that's a group of groups. But we didn't have to do that whenever we reached 10. We could do that whenever we reached any number we wanted. So let's try binary for a second. See what that looks like. Here we go. So we're always going to start with the ones place. Because the ones place, we need to count anything at all. You always have at least one thing. So now let's say I have 1 apple. So I'm going to say, okay, 1 apple. And then I see another one, 2. Well, right now, I could say 2 apples, or I could say, well, that's a group of apples. And you say, how much is a group? And I say a group is 2. So that is now 1 group of 2 and 0 left over. So if I add another one, now I have 1 group of 2 and 1 extra. And maybe I should put 2 down here. So if I add another one here, I say, okay, well, this is 2 groups. But remember, we decided that whenever we reach 2, that was when we say we have a group of those things, right? So instead of saying that I have 2 groups of apples, I say, well, I have one group of a group of apples. So what's here is a group of apples. So similarly, whenever I have two of these, so 1, 2, 3, 4, now I have two groups of groups, right? Here's a group, this is a group of a group, here's a group, this is a group of a group. So when I have one group of a group, I say I have one here of a group of a group of a group. So 1, 0, 0, 0 is I have 0 apples, 0 groups of apples, 0 groups of apples, and I have one group of a group of a group of apples. So for base 2, that's what this means. Basically, the way you do it is for any particular base, you start with 1. Then you have your group. Then you have your group of a group. So group times group, which is maybe group squared. Then here you have a group of a group of a group, which is group to the third. That's how many groups of groups you have, and so on and so on and so on. So when you hear base 2, that means that I'm going to decide that a group is 2 things. Base 3 means that a group is 3 things. Base 4 means that a group is 4 things. That's what binary is. So I'll tell you real quick, what happens if we have something bigger than 10, right? We don't want our base to be 2, we want it to be 16. This is hexadecimal. Computers use it a lot because it's easy for computers to think in. Well, that's a little bit more annoying. And this is why. Let's say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 things. Well, what I want to say is that I have 11 things here. But notice this is already 2 things, right? This is me in my normal base 10 monkey brain saying, oh, I have a group of groups of 10. Oh, I have one group of 10 and then one extra. I have 2 digits here, which is not what we want. So when we have bases that are higher than 10, we need to actually make up new symbols. We need a symbol, one symbol, that means 11. And we don't have a symbol that means 11. You can make one up if you wanted. You could say maybe this is going to be 11. Or maybe this is going to be 11. But we don't do that. We do something else. We say this is 11. So our digits go 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we need one for, my bad. This is 11. So now we need one for 10, for 11, for 12, for 13, and so on and so on and so on. We just start with the alphabet because it's easy for us to come up with the alphabet. So if you've ever seen one of these weird numbers in a computer where it says that you're at number 37A0BC, this is hexadecimal. And this number will tell you how many ones you have, remembering that A is 10, B is 11, C is 12, etc. This number is how many groups you have, and a group we decided is going to be 16s. This is how many groups of groups you have, or 16 squared, and so on over here. So hopefully that makes sense. Hopefully you understand why we do it. We use binary because computers only really can read 2 states, right? Computers cannot read numbers like we can. They can only observe basic physical properties like magnetism or electricity. And a lot of basic physical properties only come in groups of 2. Anyway, that was cool. I hope. Bye.